Hey everybody, welcome back to the Puzzle Creative YouTube channel for escape room owners. And today we've got a great one for you. We are going to talk about how to create your own prop controller that never breaks for less than $30. Before we dig into that, let's do a quick review of exactly what a relay is and how it works. So come on over to the board with me, let's go. So what is a relay and how does it work? For starters, let's draw a power supply on the board. So if we have a 12-volt power supply with a positive terminal and a negative terminal, and we want to do something like turn on a light bulb. We have our light bulb over here. To turn it on, all we have to do is connect the positive side of power and the negative side of power directly to the light bulb, and the light would come on. If we wanted it to be operated by a switch, we could break this connection and we could insert a switch. This will be like a light switch on your wall that's manually operated by turning a lever up and down. The difference between this and a relay is that a relay, instead of being operated by hand, is turned on and off by the presence of or the absence of electricity. So inside of a relay, you would typically see something like this. We would have something called common, normally closed, and normally open. We would also have two other wires, which are where we're going to activate the magnetic coil that moves the switch inside, and it gets activated when it is connected directly to power on the positive side and negative side. If it gets connected to power, it would go from this state to this state, and that is how a relay works. All right, now that we've got the basics of a relay down, let's start digging into some details. What type of relay should you buy? Where can you get them? So if you just do a quick search on Amazon for 12-volt relay, this is what you'll see, and you'll see some that look like this. There are two main styles. This one that looks like sort of a black cube is called a Bosch style relay. You might also see some that look more like a computer chip like this. They both function essentially the same way, and you could use either one of them, but for our purposes today, we're going to use this Bosch style relay, which has the relay on top and connects by a wiring harness here to 5 wires that come out of the bottom. Now, the typical uses of a relay in an escape room, of course, are to turn off a maglock or to turn on a light or something like that when a puzzle is solved. And you may already think, oh, I know about the basics of relays and how to use them in these simple applications in escape rooms. But do you know about latching relays? Latching relays unlock a brand new world of possibilities in your tech setup. Let's go back to the board and I'll teach you about how to create a latching relay and what it's good for. Come on. So what is a latching relay and how does it work? Let's jump back into our example of a 12-volt power supply and a light bulb. So if we have our 12-volt power supply, which has a positive terminal and a negative terminal, and we have our light bulb that we're wanting to illuminate over here. If we run our wire directly from positive side of power to the light bulb and negative side of power to the light bulb, it turns on. The light bulb will turn on. As we said before, we could break this wire with a switch. And if this is a momentary switch, meaning I press it and the light bulb comes on and I let go and the light bulb goes off, that's one way we could complete the circuit. This could also be a relay. If this were a relay, this wire would be normally open, this one would be common, and there would be another over here that's unused in this case, which would be normally closed, coming out of this side. And as we discussed earlier, a relay that we're using would have 5 wires, so the other 2 wires would be power to the relay. If we run the positive side directly to the positive side of power here, and the negative side directly to the negative side of power here, we would activate our relay, and on the inside, this switch would go from connected to common to normally closed, to common to normally open, and that would turn on the light bulb. So if we wanted to break this here and add another switch, it would return this back to its default state and the light bulb would go back off. If this were a momentary switch, now we're right back where we started, where we press this button, light bulb comes on, we let off of this button, light bulb goes off. It's exactly the same as earlier. Well, why in the world would we do that? Well, we're not finished yet. If we want to convert a momentary switch into a permanent output, let's say we wanted to push this switch once and let go and have the light bulb stay on. That's where a latching relay comes in handy. To create a latching relay, we're going to create another connection between the normally open wire back to the wire that connects the relay to the negative side of power to create a feedback loop. So now what would happen if we've made this connection? If we were to press this button and close this path, it would cause the relay to get activated, and on the inside of the relay, it would again go from common to normally open. Now watch this. The flow of electricity is going here, which caused the relay to get activated, but also the flow of electricity is now going through the relay into the light bulb, illuminating the light bulb, which we knew, but it does one more thing. The flow of electricity also goes from the negative side of power through the relay and to this junction point, back to itself, and it causes the relay to stay activated even when this momentary switch is no longer connected. So if we let go of this momentary switch, and now power is no longer flowing through this branch, however, it is still flowing through to the relay and leaving itself activated because power is flowing from the negative side of power through common to normally open, back to itself, and creating this virtuous cycle where it stays activated. Now it will stay activated permanently until we reset the latch. Usually where we do a latch reset would be by breaking the connection here between the negative side of power and common. So if we put another switch in here, let's say that this is a momentary switch, we'll want it to be normally closed where without pressing the button it creates a connection. So if you're using an arcade button with a micro switch, you would want to connect it on the common and normally closed terminals. And then to reset the latch, we would press that arcade button, causing it to momentarily disconnect like this, and that would cause this flow of electricity to go away all the way down. The light bulb goes off, but then also it is going to lose this feedback loop of electricity going back to itself, and that will cause the relay to get switched back to its default state, which is common to normally closed. And we have broken the latch. We let go of this momentary button. This reestablishes connection, but the circuit does not get activated again until we were to press this momentary button again. And that's a latching relay. Okay, so here's a real world example of the diagram we just drew. We have our 12 volt power coming in here. We have our relay, which we have set up as a latch. We have our light bulb and our two buttons. This button will be the one that activates the relay, and then this will be the one that kills the latch. So again, the magical thing about this is the ability to press a momentary button and have the lights down permanently, like this. And the light will stay on forever until we hit the latch kill button, which is here. And that's a latching relay setup. Now that we understand the basics of the latching relay, let's talk about some of the applications. You know, one very common type of prop or puzzle in the escape room world is a sequence, meaning needing to press or place things in a certain order one at a time. Like a keypad. A keypad would be a type of sequence. So let's say you have 10 digits in total to select from, and your correct sequence is 1, 2, 3, 4. This is something we can use latching relays to solve. So let's say that we need to make a keypad for a new room that we're building, but maybe something like this just does not fit the theme. And we want it to look something more like this. We can do that by soldering the buttons into that keypad, but those keypads typically have a timed entry where you have to enter the correct sequence within a number of seconds, or it times out and you have to start over, or you have to press enter code or pound at the end of the code, and those are two limitations that we're just not able to accept when we're building some props. The other path you could take would be to buy an expensive controller out of the box or off the shelf, like from Fright Props. But again, those are pretty expensive, and typically they're capped out at about 8 inputs, and if you need more than 8 inputs, well, you can't do it. What we can do instead is we can use the magic of latching relays to build our own. So let's get into it. Now we're going to get into the nitty-gritty details of exactly how to build your own prop controller using latching relays. So let's jump into it here. So let's take a look at the schematic that we've drawn up for our relay sequence lock. And I will tell you, this has been a closely guarded secret for several years, and we are releasing it to you today. The buttons that are shown at the top here indicate that this is drawn out for a 5-button sequence. So if you were to use this as a keypad, it would allow for 5 digits in the correct sequence. So let's say 1, 2, 3, 4, 5 could be the correct code. All of the squares that are on here are relays. This row here are all the latching relays. We have another row here of 4 reset relays, and then 2 other relays down here at the bottom. One takes care of killing the latches if the wrong button is hit in the wrong order. And the final signal is where you connect your output device like a mag lock or light bulb. If this looks too complicated, don't worry about it. I promise you, if you can follow lines and recognize colors, you can put this together. You can wire this up. One thing to note is anywhere you see an X over 2 lines that intersect, like here or here, that just means those wires don't connect. If you see a spot where there's a red dot, that means that the wires do connect. One more important thing to note, you see this note at the top, it says 12 volt positive connects to black on all relays. So each relay has 5 wires, a white, a black, blue, red, and yellow. All right, so we've got all of our relays prepped and labeled here. We have our 5 latching relays, 4 reset relays, and then a latch kill and a final signal relay here. All of these you can find in the diagram. And then we also have our buttons prepped over here. For this setup, we are going to use 6 buttons. 5 will be for the buttons that are in the correct sequence, and then 1 that is sort of a negative or wrong button for this example. So I'm going to go ahead and start putting these together. The fun thing about these relays is you can actually connect them all together like this. So once we have all of them connected, this is what it will look like. It's 1 unit now, and we're going to start connecting all the wires according to the wiring diagram. The best way to do this, I find, is just to start over on the far left with latch 1 and follow the diagram. So I'll just grab a wire and then see where yellow is supposed to connect on the diagram, and we'll go from there. One thing that's important to note is on each of the latches, any of them that are labeled latch, by definition, white and yellow are going to go together. So I can go ahead and go through and do all of those. So I'll put white, yellow together there and on all the other ones. All right, so we've got all of the white and yellows tied together on our latches. One other thing that's good to do at this point is to go ahead and connect together the black wire on every single relay. It may be good to do a couple of bundles so we don't have so many wires under one wire nut. All right, so we have all of the black wires connected together, and we're going to tie those directly to the positive side of power. So we'll flip back over here, and one thing that is good to do as we're going along, just to stay organized, is to go ahead and label some of the wire ends where we're not ready to connect them yet, but so we don't lose track of what they are. So I'm going to label this one positive side of power. So we have positive power in labeled there, and then we can continue. Next, you could take all of the blue wires, which are the commons on the latches, not on the resets, but on every latch you could take the blues, and on the diagram you'll see that those are all connected together. Okay, now this wire that I have that connects to the common or the blue on all of the latches is going to connect to 2 different spots. It's going to connect to normally closed on latch kill, and it's also going to connect to the common terminal on button 1. So let's go ahead and do that. We'll go ahead and label button 1 here as well. Okay, so what we have left on latch 1, the only wires we have left are white and yellow, which are the negative side of power, and normally opened, which are of course tied together to create our latch. And you can see in the diagram that these are going to connect to 2 places. We're going to connect it to the other side of our button 1, which goes to the normally open terminal on that button. And then we're also going to connect it to white on reset 2, which is going to provide it with negative side of power. So we'll connect those together. One thing we can also bundle together are the red wires on the reset relays. These are the normally closed wires. So let's take all of those and we'll tie those together, and those will connect into the latch kill relay. So let's get all the reds on resets here. Okay, and these 4 red wires from the reset relays are going to connect to 2 different places. On the wiring diagram you can see that they connect to the white wire on the latch kill relay, which is here. And they also connect to the normally open terminal of our wrong button. So if this is going to be our wrong button, we'll connect that in here as well. So next we're going to take the 2 remaining wires on reset 2 and find where they go. So the common wire, or the blue on this, is going to connect into normally open terminal on button number 2. So we'll grab button number 2, we'll connect this to our normally open terminal on button 2. And then we have the yellow wire left on reset 2, which is going to connect into latch 2 on its white and yellow, which are tied together, of course, because it's a latch. So these will go together. We also need to connect this into the white wire on reset 3. Okay, now that we've finished one entire section going from a latch to a reset into the next latch, we'll continue this pattern all the way down, following the diagram until we're finished. One important note here is when we get to the last sort of button, or the highest number in our sequence, which is 5 in this case, the yellow on the 5 reset is going to connect into the white and yellow on the 5 latch, but then we are going to change up the pattern here, and that's also going to tie into the white wire, which is going to provide the negative side of power to the final signal relay. Okay, so one thing I'm doing here is I'm preparing the circuit so that I have an easy place to plug power in, which is going to be here. I'll plug positive and negative side of my 12-volt power supply in here. So the label we created earlier, where I have power, positive side of power in, that connects to the black wire on all the relays, is connected on one side of this here. And then what's going to go in here on the other side is we need 2 wires that go in that will get the negative side of power, and that's going to be the blue, or the common, on latch kill. And then we also need the common terminal on our wrong button. So these 2 things will merge together, and we'll put those into this clip so we can connect it to the negative side of power. So another thing we need to do at this point is to take all of the common terminal wires from our buttons, and we are going to connect them together, and those are also going to merge into this clip and get the negative side of power, along with the 2 other wires we just put in there. At this point, the best thing to do is to double check and make sure we don't have any wires that are left over that we haven't connected anything. It looks like we're all connected, so now we're going to clean everything up, do a little cable management, and make it look better. So once we have everything cleaned up, this is what it's going to look like. We have our 5 correct buttons here, our incorrect button over here, a connector for our power input here, and then we have a final signal, which we can use common and normally open if we were to do something like turn on a light, or we could use common and normally closed if we wanted a mag lock to stay on until this was solved and then let it go. So let's go ahead and get power plugged in and give this thing a test. Okay, so I've also connected our light into our final signal relay here at the end of the whole sequence. And of course, we have to connect the light directly to power on the positive side, and then we're going to run the negative side of power through the blue and yellow on our final signal, so that the final signal relay is breaking the connection right now, and when we finish the sequence on our 5 buttons, it should provide power through this, and then leave this light on until we hit a wrong button, which effectively kills all the latches and then resets the prop back to the beginning state. So let's give it a shot. So we go button 1, button 2, button 3, button 4, button 5. And our light comes on, and it works just like magic. We have our keypad relay lock that we've created. And the beautiful thing about this is you can stretch this to as many inputs as you'd like or as few as you'd like. The only thing you have to do is the same way that you connected latch 5 and reset 5 differently than you did the ones before it. You would just make that same thing for the last digit in your sequence, and you can eliminate any of the ones that come before it. And so that's how you can adapt this for larger or smaller number of inputs in your sequence. Okay, let's say it's time to reset this. The game is over and the game master's going in to reset the game. All they have to do to reset this prop then would be to hit one of the incorrect buttons in the sequence, and it turns off the light and the prop is reset. Okay, so let's say that instead of entering the 5 buttons in order, somebody gets the order incorrect. So if we went 1 and we skip 2 and we do 3, 4, 5, and then we go back and hit 2, it actually does not turn on the light bulb. To reset, I'm just gonna hit an incorrect button. Let's try it again. This time let's skip the next one. So we'll do 1, 2, and instead of hitting 3, I'll go 4, 5, and then come back and hit 3. So I've hit them all but in the wrong order, and our light does not come on. And we'll reset again. So if you have a, let's say, keypad setup that has more than 6 buttons and you want 5 to be in the correct sequence and you want the other to be incorrect, all you need to do is take each button and wire it into this wrong button or other buttons wire that's shown on the wiring diagram in parallel. So each of the buttons would all tie into this same line in this circuit diagram. And if you hit any of those at any time, it resets the entire sequence, and then it requires you to start over like this. So if I were to go 1, 2, 3, 4, and all I have to do is hit 5 to turn on the light, but then I hit a wrong button, it's going to reset the whole thing. So hitting 5 now does nothing. And I have to start over and do 1, 2, 3, 4, 5, and turn on my light. And that is how you make a keypad relay sequence lock. So that's it. Once you've wired up all the relays like this, the next step is going to be to connect your inputs. Your inputs could be as simple as arcade buttons, or you could embed buttons into a more complicated prop, like the one shown here. But either way, once you've done that, congratulations, because you just built your first prop controller for under $30. Now, if you're wondering if there's a way for you to adapt this for different types of things, for instance, if you need to have a code sequence that includes the same digit multiple times, let's say instead of 1, 2, 3, 4, you need it to be 1, 2, 3, 2, and repeat the 2 digit. There is a way to do that. It's too deep to get into for this video, but if you want more instruction on this topic, be sure to check out our conference coming up in September called PuzzolCon. PuzzolCon.com, and you can check out the link in the description below. It's going to be a great opportunity to network with other escape room owners, but also we're going to dig in and do a lot of hands-on workshops exactly like this one, and we can answer specific questions on how to customize the relay sequence lock diagram to fit your needs. And if you want more content like this, please be sure to like and subscribe.